All right, cool. Claire, want to kick us off?
Yeah, hey everyone. Thank you so much for joining. My name is Claire Longo. I lead customer success here at Arise, and I'm also tinkering with LLMs in my free time, as I'm sure a lot of y'all are. We've got a great paper that we're going to talk through today, and it covers some really cool topics around RAG and re-ranking, but it does not at any point describe what those actually are. So I'm going to give like a little bit of a quick overview of like ranking models and re-ranking, what that really is before we dive in here. So let me pull up some slides. Great. So the first thing I want to cover here is like, what is ranking in the first place? So I think a ranking models is really like two core kinds here. There's recommender systems and document ranking. And specifically, we're going to be thinking about document ranking right now, but kind of the bones of how these models work are very similar. Essentially, what you've got here is you've got input data that gets turned into features. So in document ranking, you're looking at a query and documents. So you have embeddings that are representing those. And you have some kind of ranking model. Now, the architecture of this can definitely vary. Like you could have some kind of simple cosine similarity system here. You could have like a deep learning network that's like a hybrid recommender system. But the output is always going to be a ranked list. And so that's what makes these kind of learning to rank models special. They're different from classification, different from regression, different from NLP in the sense that they are predicting not a single value or item, but they're predicting what the rank is of a list of items. So in a situation like this, the output would be a list of ranked documents. You want your best documents at the top, your worst documents at the bottom, and we're ranking based on a score. And the score is usually some kind of like engagement metric, like it can be like probability of a click, probability of a purchase, probability of reading a document end to end, whatever kind of signal you can get here, but the model will be trained to optimize and predict that score, and that's what it's used to do the ranking. So that's what the predictions look like, but then you get into what do your actuals look like what's your feedback loop? In a lot of these situations, you will get a label as the actual, so you'll get something coming back saying, giving you some kind of signal of like, was your ranking right? Did people actually click on that document? Giving you that indication of like, was your ranked list good? Did you have your best items at the top? So that's document ranking. Let's jump into the cooler stuff, which is LLMs. So RAG is a really common pattern in LLM architecture today. It's retrieval augmented generation. Essentially, what these systems look like is like you have a user query coming into the system, and you're using that query to get some kind of response out of your LLM. So you'll have essentially the system that is orchestrating the query with the context data, that kind of corpus of documents, as well as making calls to your LLMs, formatting response, and maybe collecting any user feedback if you have it. The really interesting thing about this is re-ranking and how that might fit into a system here. So this system doesn't show re-ranking. It's essentially just doing the query step. You have the user query. You reach into your vector store where you've embedded and shoved all your documents and chunked them up. And then you are retrieving, let's say, top K relevant documents. So it's not necessarily optimized for ranking that list. It is optimized for retrieving you the most relevant content. So the retrieval is trying to get relevant stuff. It is kind of ranking to do that. It's usually like a cosine similarity kind of operation there. But what you're really trying to get out of the step is like, give me the most relevant content to augment into this prompt and then pass into the LLM. The re-ranking step here is adding another LLM here in the system before you put it into your kind of foundational LLM that's doing the generation of the response. Essentially what you're doing is like, let's say you retrieved 100 documents from your vector store or 100 chunks, and you want to make sure that those really are ranked in a meaningful way with the best at the top and the worst at the bottom. So then you apply this kind of like re-ranking model system that I talked about earlier, where you're essentially like re-ranking and maybe choosing like a smaller K. So let's say K equals 5 here. So you're taking like your top most relevant 5 and then only using that going forward. So it kind of further narrows this system here.
Awesome. Thanks, Claire. And if people have questions, there's a Q&A and there's also a chat where you can get your questions answered. All right, let's dive into the paper here. And then, of course, like the other thing this paper doesn't really get into are how metrics for ranking and re-ranking are calculated. We actually, at Arise, we have a full unit on rank-aware evaluation metrics. It's one of our free units in our evaluation and metrics courses. So Arise University, we have an entire unit that goes in depth on the NDCG, or normalized discounted cumulative gain, the steps of that. If you have questions on these metrics, we can answer those, but these are the three main metrics that you see in ranking systems. And the two main ones discussed in this paper are NDCG and mean average precision. NDCG is very sensitive to rank order, and MAP is, I would say it's a little bit more digestible, but tends to be for binary cases where this where the examples we'll see through the paper are looking at a binary relevance. Mean reciprocal rank, MRR, is not really used in this, but it's another one you might see in ranking. So if you're interested in these metrics, recommend checking out more in Arise University. Okay. Perfect. And thanks, Sarah, for dropping in that link as well. All right. So we are talking about RankVicuna. I think that's how you say it, which is a zero-shot listwise document re-ranking with open source large language models. So there's a lot in that one sentence, and that's why Claire and I are kind of breaking it up. Now that we've talked about document re-ranking, this is an open source model available for the public. It's a large language model. We'll get into the zero-shot component, but Claire, do you want to talk just a second about listwise versus pairwise? I also put some information just at the top of the page, because it wasn't something I even think about often when thinking about ranking systems.
Yeah, so this is really cool. So there are some models that are specifically made to rank a list, and their output is a ranked list. There are also classification models that produce a score that could be also used to rank a list. And that's kind of where we get into these nuances. So a ranking model, let's think of maybe like a hybrid deep learning recommender system. It's going to take a list of items or documents, and it's going to produce that ranked list as the output. Another way to get a ranked list would be to feed a document into a classification model one at a time, get a score, and that score is again going to be probability of click. It's just going to be that score that we use to rank. And so you could pass those same documents through more of a classification model and then use that score to rank. And that is difference between the listwise and the pointwise. Listwise is you are returning that list right away and ranking those documents together through one call to the model. Whereas pairwise is do I have these right? Yeah, so pairwise is you're predicting that score and then using that to rank the documents individually. I think there's kind of trade-offs here, because when you're doing listwise, you're considering the other documents almost as additional information or context to help rank that list. Whereas when you're doing more of the pointwise approach, you're not necessarily looking at the other documents to determine what the score of the one document that you're interested in should be. And so it's a little bit blind to what else is in the list. And that's kind of an interesting thing to think about when you choose which approach. So here we're talking about listwise document re-ranking.
Okay, awesome. Thanks for that. All right, so looking at just a few things about the abstract before we get into the depth of the paper. Essentially, their claims are that RankVicuna is the first of its kind that's open source, has this LLM capability, performs re-ranking in a zero-shot setting. So zero shot, it's not given a bunch of examples. It's just essentially asked the question, when you use ChatGPT and you're asking it a question, gives that response back. You're not giving it a bunch of examples. You're not doing few shot. You're not doing chain of thought learning. If you're interested in learning more about zero shot versus other prompting techniques, I recommend checking out the prompt engineering guide that goes into depth on the different types. But basically, zero shot is just a single action, and it's the most straightforward and most commonly used. It's definitely the benchmark if you're testing out against different prompt engineering methods. So that's when you see like the zero shot setting. That's what we're seeing here. But it's saying that it is just as effective as some of these other zero shot re-ranking with GPT-4, GPT 3.5, but it's a much smaller model. So this is a 7 billion parameter model, and their effectiveness is essentially on par, but you have a much smaller model that you're using for this re-ranking step. And going back to what Claire mentioned, that re-ranking step is after you select all the documents. So, okay, I have all the documents I need. Now I'm going to go back through and re-rank them. Like essentially, if you have an assistant and you say, get me all the files on this case, and that assistant goes and gathers all the files, you might want to like re-go through the files to organize them for a certain type of priority. Okay.
A really
again,
good kind of example to frame like re-ranking versus retrieval. Yeah.
Yeah. And I think because the other thing this paper gets into is the open source versus these proprietary models, and the fact that we don't have access to them. And right now, the proprietary models, like all the GPT models, are performing so well, but open source is improving at a constant rate. So they're still not as good, but this paper is pointing out the advancements that are being made, especially for individualized cases and special use cases for these open source models, how the effectiveness is steadily improving over time. So it's just interesting to see, like, when GPT-5 comes out, how much better is it than these other models, and how much better is it than other open source models. It also gets into RankVicuna being deterministic. We'll get into that a little bit later, because that is definitely was non-trivial for us when we were going through the paper. Claire, anything you want to talk about in like the background or related work? I know it because you already explained the pairwise versus listwise. There's different components there. But anything you want to mention before we go into some?
I think we covered it really well. When I was reading this paper, I was looking for two things. What is the value prop of what they're doing here? Like, what value could it bring to my workflow today? Or could I use as like a jumping off point for additional research? And then also just like, how are they measuring good? They mention in the first few pages of the paper here that it performs as well as a larger model, but like, what does that mean? Like, what is performs well mean? And so that is something that we'll get into, and like how they're actually measuring the value of the re-ranking here, because re-ranking is becoming a very popular part of like an LLM system. And that's something that I was thinking through a lot of, like, why are we even doing this? What's the value of it?
Mm-hmm. Yeah. And it makes sense when you're going from traditional like recommendation systems, where that rank that you were given is already based on like some of your specifications for if you're using like collaborative filtering and what you want to do there, versus using an LLM, which can hallucinate, like you don't know exactly what's going on under the hood. But a re-ranking, you have a bit more control over there. And especially if you want to get into like personalization, then that re-ranking step I do feel is necessary, but I wasn't really thinking about it too much before reading this paper, and just like starting to have those thoughts of like, oh, like, why is this necessary? What is the value prop?
Why are people doing this? And I think you're exactly right. And another thing that I was thinking about was kind of letting different LLMs and like prompt pairs, like a little bit of like a component of your LLM system, separating it out and letting different components be good at different things. Like I have a retriever system and it's really, really good at retrieving, but I'm not necessarily optimizing that system to rank. But now I've also got a re-ranking system that's really, really good at ranking, and just let those two systems be separate and be good at what they're good at.
Yeah, oh, that's a great point. The other thing I just wanted to highlight was the mention of Hyde. We do have a full paper discussion on the Hyde paper, one of these community paper discussions on our YouTube channel. So if you're interested in that, and I believe, Claire, correct me if I'm wrong, but I believe the Hyde approach, what's special about that is like when we put in a query that we're then collecting documents for, the normal process is we put in the query and then that's connected to our vector database, and all of our relevant documents are selected based on that query. But Hyde generates the response, and then the relevant documents are based on this kind of created answer. And so instead of it being all the relevant documents being based on the question, they're actually being based on this created answer that's generated from another LLM, which is really interesting when you think about it, because that's Hyde's trying to show, like, these relevant documents might be the most close to this created answer than they are to the actual question, especially like in that vector space.
Yeah, that's fascinating.
Oh, thanks for linking, Sarah.
Yeah.
You found that fast.
Awesome.
But yeah, another reason why Claire and I picked this paper, we love ranking, we love recommendations,
I like
and
the rank thing.
yeah, anything ranking and recommendations, especially with all that we're seeing in industry use cases. Like every team, regardless of industries, has some kind of ranking, some kind of recommendation, even if it's internal versus external, and everyone's trying to see how they can leverage LLM for this use case. Let's see. I think here I just kind of highlighted that, again, they're talking about prompting methods. They're talking about evaluation metrics such as NDCG, which we talked about a little earlier. And then this is the prompt. Claire, anything you want to say on this prompt?
Okay, this was fascinating to me because I come from a background of like boring old tabular traditional recommender systems. And in this new age with new technology, ranking becomes just like a very different kind of system under the hood. So the way that they're ranking is actually through a prompt. They have constructed, through some very good prompt engineering here, they've constructed a prompt where the output is going to be that ranked list. So it's not just necessarily that the model is trained to rank and we're leveraging that, but we're really just leveraging the power of a language model with a very good prompt that inputs a chunk of documents, just like a model here would, and outputs a ranked list. So really kind of cool to see that this is really a strong prompt engineering problem.
Yeah. And I think we've shown a few times the differences between fine-tuning versus prompt engineering, when you might want to use one over the other. And I think here, yeah, just being able to even specify and change out this this prompt, you can have slightly different ranking systems that are maybe specialized to your own company, and yeah, things and trends you might have seen. It's definitely easier to do this over fine-tuning, but that's a different conversation. There's
You always want to start there. See what you can do with the prompt first.
Yeah. Agreed. All right. They talk a bit about the training process, and then we get into the experimental setup. So they're not using just GPT-4 for a re-ranking. They're using these rank GPT models that they're referring to as rank GPT 3.5 and rank GPT-4. And so these are re-ranking systems from research that are using these other models, and that's what's being used there. And again, the model that we're looking at, the RankVicuna, is 7 billion parameters. And they do include a few other open source options as well when doing the comparison, but nothing really compares to RankVicuna and the re-ranking for GPT 3.5 and 4. A bit more on the experimental setup. They're using the MS Marco passages for their data set. So you're going to see like DL19 and DL20 referred throughout this paper. These are the data sets that they're using for ranking, re-ranking. They go a little bit into the context size. So context size, very small for Vicuna, half the size compared to GPT 3.5. If you're interested in like the sliding window, training times, they get into the paper, but we're going to get a bit more like into the results here. And there's
Amber, before we go to results really quick, there was something that stood out to me on the training part. First of all, they never use the word fine-tuning, which is interesting, but they are training these models. The thing that stood out to me is that the way they generated some of the data here for training, or maybe all of it, is they generated query and ranked documents as a response. They generated that data, that training data, from another larger model. And I thought that was really kind of creative and cool, because isn't that like a great way to get your smaller, cheaper model to learn some of the patterns that this larger model might have already encoded by just training your smaller model on like a larger, or like data generated from that larger model.
Yeah, because it's interesting that like we keep hearing like this is a smaller model, but it's almost like if you think of like hyperparameter tuning on that, and you're like collapsing layers and you're just making it smaller. That's what it is, and it's a clever way of doing it with the model a lot smaller, but you also can't have this model without those larger ones. So you can have the large ones without the small ones, but you can't create those small ones without these larger models. All right. Yeah, and the rank GPT 3.5. So these are like 175 billion parameters. So from what we're seeing highlighted here, 4 or 5, rank GPT 3.5, rank GPT 4, and RankVicuna. This is different sources here. I haven't heard of Splade, but it's some kind of ensemble method. And they claim it's a state-of-the-art neural first stage parse retrieval method. So like for different stages of that re-ranking. So it's like an added step. So you would expect performance to be better with this added step, and performance, your NDCG at 10. Now this at 10 is just the at K value. So within the 10 documents, and then this mean average precision at the first 100 documents in that re-ranked list. And the performance does improve with this added step. But the overall findings from this first piece of information is that this 7 billion parameter model achieves comparable performance to these proprietary models of GPT 3.5, GPT 4 that are about 20 to 30 times its size. Now, Claire, does it talk about how fast it is at all, like throughout this paper? Maybe we're jumping the gun a little, but there's a big emphasis on the size of this model compared to the size of these large language models, for a step of re-ranking. So any thoughts there?
Yeah, it's really interesting. So the metrics here are great. These are traditional ranking metrics. You got your NDCG, your map at K 100. So that's great for like measuring the quality of the ranked items, like how good is the system at actually ranking a list. We're also looking at, in the smaller table there, some consistency in the output, which we'll talk about a little bit more. But what I did not see anywhere here was like, how fast is it and how does it compare to others? But That being said, this is definitely like a really cool open source model that you have full control of to look under the hood and use. And it's something that could be built on. So I think it kind of lay some really good foundations here, even if it's not like fast enough for production yet. It's definitely, I think, worth looking into.
Mm-hmm. Yeah, and so the second table that Claire is talking about is the number of malformed responses for each re-ranking method. So here we see so the total is the same for each, the total responses, and then we get missing, repetition, wrong format, and okay if it's what is expected. The wrong format here includes responses that do not have a given requested format, which GPT-4 re-ranking isn't doing too well on. For example, yeah, it's saying rank GPT-4 refuses to generate a sorted list. So that falls into this category. Repetition here includes responses that contain repeated document IDs. So it's not so that because like they're trying to do like a one-to-one mapping, like making sure it's correct. So if they're repeating documents, then that's not correct. If they're getting a format wrong, that's not correct. And then missing includes responses missing document IDs. So like a mismatched part for the document IDs, which seems to be GPT's lowest part. So getting the wrong format is happening more for GPT-4. Hardly any repetition, but there are a few with missing document IDs. But RankVicuna scored, no wrong format, no repetition, no missing. And Claire and I were talking, we think like this is where they say it is non-deterministic. No, so this is where they say it's deterministic, and it's not stochastic. So with LLMs, we assume all of them are non-deterministic because every time you run them, you get a different response. But the re-ranking that RankVicuna does, they're saying like you're expected to get the same thing every time. And so it's a deterministic model in that perspective, in that perspective.
Yeah, this threw me through a little loop. Amber and I were on a call just deep diving into it, trying to figure it out, because there was one like trigger word that Amber noticed, and I didn't notice it, but earlier in the paper, actually, if you scroll up to where we first highlighted it, they used the word deterministic. And that was so strange to see in the context of a large language model system, because large language models like this, the way they work is output is probabilistic, in the sense that the language model is predicting the next token in the sequence. And there's a probability of the right token. And so when you rerun this model with the same query, you've got like a little bit of a confidence bound around what that token could be, and you could actually see like a different token for a different run. So you're not going to see the exact same output with the exact same input with these models. And so that was very strange. But then when I think about the task of re-ranking, you do want consistency in the format of the output, in the sense that you want a ranked list, and you have specific things about that ranked list, like you need the document ID, you don't want documents to repeat each other, things like that. And so you do need, in a sense, a deterministic system here that's going to be consistent and give you a ranked list. And I think that's what they're trying to highlight here with the smaller table and what Amber's talking through. It's really interesting stuff.
Yeah, and they say like, since RankVicuna is deterministic, they're just going to report the results of a single run because it's the same for every run. It doesn't get the wrong format, it doesn't get repetition, it doesn't get missing. And yeah, like the three ways you can think of just any model in machine learning, like, is this probabilistic, is this stochastic, or is this deterministic? Like, is this going to make decisions based on a probability? Is this going to give you the same results every single time? Or can it give you, is it like shaking a magic 8-ball and you're going to get different results every time? Because that's the stochastic nature, and like stochastic gradient descent comes from that. And
it's a great comment talking about the speed and how that would depend on the hardware, the deployment system. And Amber, I know like you were looking at this at the end too, so I think we can circle back on that one.
Yeah, I think the only other thing I had highlighted here is the mention of prompt costs, that it is cheaper to use RankVicuna for prompt cost in comparison. But again, we're not getting the information on speed for how fast it is, which tends to be the most important for users. Like if I'm loading my Spotify like search results and getting my ranked list for recommendations, if my recommendation is the one I want is second or third, versus if it takes, if it's like instant versus it takes a few seconds, I'd rather it be extremely fast and my result be there. So decent ranking, but very fast output, very low latency, than me having to wait for those results. Okay, yeah, and I think this is pretty much just more information on malformed responses, results here. We're seeing the same thing, that everything is comparable to where RankVicuna is comparable to all these large language model re-ranking systems. Trying to think if there's anything we wanted to go into much more, because we're seeing like these first stage candidate generations with repeated experiments. They're using a bag of words model, so just essentially doing word counts as their baseline when they're doing comparables for these different first stage candidate generations. And then the other thing we're seeing is data augmentation aspects, where the training process for RankVicuna, they highlight the use of data augmentation as a crucial step in their training pipeline. Now, note these aren't very large data sets, and that's one reason why there is going to be a lot of performance when you do see this data augmentation step. Claire, do you want to talk about the augmentation at all?
Yeah, I think they were doing some interesting stuff on the augmentation, but actually didn't go deep here. What jumped out to you?
I think you were mentioning this before, that like teacher student relationship, that's for that augmentation step. So they're saying this data augmentation steps involves like the shuffling of the input order of the documents. And so it's not like how I normally think of data like augmentation. It's more shuffling is what it seems like here, and then using that to provide like a teacher model.
That's cool. So essentially what they're doing is they're like generating training data examples from that larger model, and then they're augmenting those samples by shuffling things around, really just trying to like give more examples to the model to learn from here.
Yeah. And I think this is, like I said, I think this was necessary because this is not a very large training data, but this is a great example technique that you can use if you don't have a lot of data. The way we the way we create like synthetic data to help train the models for use cases. This can be a really good thing to use if you're not, or if you just don't have that much data and you want to be able to use ranking and re-ranking systems. So that was just one thing there, essentially being that you get better performance if you do this augmented step in that process before you do the re-ranking. So, okay. Let's see here. Okay, and more results. More results around there. And then kind of just getting into conclusions. So what we're seeing with the conclusions, or what we've been talking about throughout this paper, we're going to highlight the kind of the main things that this paper shed light on, what we've been using it for, what we might use it for in the future. And then Claire, we could talk about things we'd like to see in the future, and kind of like what we might need, what we might need as someone who understands working in production, like what we would need in order to find RankVicuna as a viable approach to use in production. So let's start with our takeaways. The big takeaways being that, okay, this model is 20 to 30 times smaller than the re-ranking models that leverage GPT 3.5 and GPT 4. So that is great. This is incredibly stable. There's, it's a deterministic approach where you're getting the exact same results. You're not getting, a bunch of documents that are missing IDs. You're not getting documents that aren't following the ranking structure that you provided in the prompt. Yes, bring Xena in the frame. Let everyone see. Yes. Okay.
She's also part of the paper reading.
Yes, Xena's also part of the paper reading. I'm always excited to see dogs. My dogs are too big for me to lift into the camera, but next time, I got distracted. Always distracted by dogs. But basically showing that they are on par with these larger models, the RankVicuna variations. They are open source, so that's another big, big area that, these models being open source, we are seeing more and more open source models improving on performance, being comparable. I would say being comparable to GPT 3.5 from the papers I've read. I still see GPT 4 coming out on top for a majority of use cases, but being able to get semi-close to that point and not having a proprietary LLM is kind of a make or break for a lot of teams. Yeah. So noting that, this is improving performance around open source large language models. It also shows the importance for data augmentation and the role it plays in ensuring like stable, how stable your document reordering can be, and like the variations, the additional steps you can take in the re-ranking order. Because not only is there re-ranking, there's like a single stage, there's these additional methods that we've seen be introduced, which can really help in that kind of first stage for that re-ranking. I think those are the main things that I'm thinking about, and the main things that they bring up in the conclusion of their paper. For me, like the big takeaway is showing the capabilities of open source large language models that are essentially condensed versions of larger models, like just how good that they can be, while also being able to change out prompt engineering. I would have liked to see more variations on the prompts, but just the power of prompt engineering, because that prompt is really what's getting it to be so stable in those outputs, and getting these results where, I think it was right down here. Yeah, getting these results here, which I thought you don't even think this should be possible, but it is very stable, and this is like what's happening now. Very large data sets, I don't know, but these results are pretty impressive, especially when you do have GPT 3.5 and GPT 4 kind of hitting the mark for wrong format and for missing document IDs.
Yeah, I'm thinking the same things. Like the stability here is really cool and highlights maybe some potential of having a system that's just really good at one thing. This system is just really good at ranking, whereas ChatGPT, as we all know, is really, really good at like a lot of things. But maybe in some situations you want this kind of consistency getting a ranked result. The other thing that's super cool is like their prompts looks excellent. I really like how it's constructed, how it's taking the documents in and forcing a rank out of it as the response. And I would love to see how they kind of iterated and came up with a prompt like that. So that's something we could dive into. In terms of like next steps, like exactly what this comment is saying here, like I'm curious to see how it deploys, how it scales, how much it costs. So I'd probably want to tinker with it in that way. And then also there's discussion around like vector databases and how that would fit with something like this. Like if you have a vector database that is very good at like efficient re-ranking before it's like returning that retrieved list of documents, do you need a system like this? I think that's kind of an open question still.
Yeah, Vivu, thank you for that response.
Right.
Yeah, it would be very interesting to see that, also see where it fits in that kind of LLM framework that Claire showed earlier. We actually found like an interesting conversation, and we have a few minutes left. So if there's no questions, I'm just gonna pull it up real quick. Kind of diving in to this topic a bit more. And Pascal's great. I find a lot of interesting papers to read from his post and from his newsletter. But this is where obviously Niles is going to be supporting Cohere. He's the director of machine learning at Cohere, but he raises interesting points of how long it can take for the step to be added into that process. That some of the comments we were getting are showing, and being able to use the document embeddings at query time, being able to connect them with vector databases using re-ranking. And so Cohere, an LLM company, it's interesting because they're thinking about this as well, and they're thinking about like the speed. And I don't think it's just Cohere. I think other LLMs, other vector database companies are leveraging this area and trying to think how to get ranking down pat and how to get re-ranking down. And these use cases are incredibly important for folks that want to leverage large language models in production, but they want to minimize that hallucinations. The paper also did mention that all this was done with a temperature of 0, so trying to get as little hallucinations as possible. So those are the exact kind of questions to think about, and how it fits in. But I think what I've learned from this paper is re-ranking is a necessary step. If you're leveraging large language models to like pool all your documents, and you're leveraging them to create a response, and you're leveraging them to decide in which order to select these documents, do you want to do it right at the prompt? Do you want to then generate a response to that prompt and then use that to find similar documents? Like there's a lot of questions around that, but it might be almost like another layer, another like human in the loop, essentially, to do a very stable process of re-ranking. Claire, anything to add in this the last minute?
I think that covers all of it. The only thing I want to point out is Amber's amazing at reading papers. She's been doing it for a while, and I learned something from her here. She went to LinkedIn and was like following this conversation in the thread around the paper, where someone had posted about it. And I thought that was just like a really cool way to just like be part of the community discussion around a paper and hear what other people are saying, kind of validate like our gut reaction to things too. So definitely something that I recommend and like we'll do going forward is just finding a community to talk to about these papers as we read through them. Don't read in an echo chamber. I'm sitting there, I'm like deterministic, like thinking I had to give her a call.
Exactly. Well, thanks everyone for joining, and we're a community as well, and feel free to talk to us. We have a great community on our Rise community Slack, and if you have any questions about this paper or other papers, please let us know. All right, have a great Wednesday, everyone. Thanks.
Thanks everyone. Thanks for the questions and comments. Bye.
Bye.